Okay, today I'm going to write some Rust, not just the live coding stuff. And what I'm going to be working on is this problem with pipelining, which I have mentioned in previous videos, in the live coding language. So the issue is that when I'm working in live coding, which has syntax highlighting now, that was a nice change. And I want to do something like, say, make noise that's been filtered or something like that. It would be nice to instead of just having this noise node, to be able to do something like this. Say, define a low pass filter with whatever parameters, and then just pass a noise node into it without having to first define an actual node name above. So basically have the graph build these nodes sort of implicitly. And that's going to be pretty straightforward. The only problem that I need to figure out is that right now I don't have a way to distinguish between node names, variables basically, and node constructors. So in fact, I often shadow. It's not really shadowing because they're different things, but so in this example, I have a node named noise. This is a node in my graph. It is constructed with a node constructor, also happens to be named noise, right? So if I'm going to do this pipelining stuff, or composition maybe is a better term, I need to be able to distinguish here, am I talking about the node named noise, this guy, or am I talking about the constructor, in which case I'm making another copy? Because I probably shouldn't do this, but I could. I could have a node named noise that was in fact not a noise node, right? And so here, the question is, do I want that noise, which is actually a sine wave, or do I want a new noise node that's actually noise? And so basically I need to introduce some new syntax to distinguish between these two. I'm not quite sure what that should look like. I mean, a lot of languages do something like, a variable is lowercase, a constructor is uppercase, and I could do that too. And maybe something like that is the cleanest. I've also thought about that's a constructor, this is a node. So having a operator of some sort. I don't know. Because of the languages that I write, I'm not super thrilled with having that uppercase. But I guess, node Rust sort of does that. Types are uppercase. And my node constructors are basically types, to the extent that my language has types at all. Okay, so now that I've said that, I think that's actually what I'll do. So I'm going to say that everywhere where a node constructor appears, I'm going to expect it to start with an uppercase. So that means this also needs to have an uppercase, as does this. In any place where I'm referring to a defined node in my graph, it's lowercase. So this is a node name, this is a node name, this is a node name, because they're all lowercase. But this is a constructor. Okay, I think that'll work. So another nice thing about this change will be that previously, when I define a node, like in this line, the only thing that could happen here is I call the constructor, right? This isn't actually an expression. It's just a constructor. But now, I think with this change, I'm going to be able to make that an expression. So I could say hey, noise is now, rather than just a sine wave, it's a sine wave multiplied by 2, right? So currently that's not legal, but I think after this change it will be. And I think that's going to simplify a bunch of the code that I write in the live coding language. So I'm pretty excited about this change. And let's move to the Rust. Okay, so this is going to get us down into my parser, which is I don't know. It is what it is. This is really the first time I'm writing a language parser, so it's pretty ad hoc. I'm using POM, which is a parser library for Rust, and it works pretty good. Again, it makes sense to me. I think I sort of wrapped my head around it. So the structure of this is I've got this sort of one function. This is it's a method on my graph, the thing that contains this dynamically constructed version of the DSP graph at runtime, and so it's got a method. Or a static function, I guess, that takes the string, which is just the text contents of this file, and parses it into a intermediary representation, which for various reasons I'm currently calling line of echo lines. It's not really an AST. It's just it's sort of a crude parsing of the file. I think the compiler people have a term for that. I just don't know what it is. It's like the first pass, And then later on, I use that to actually build the graph, which we're not going to look at that code, I don't think, today. It won't be necessary. We're just going to look at the parser. Okay, so first off, let's look at the places where... So the way POM is structured is you define these little functions, each of which returns a parser that parses a part of the overall language, and then you combine those together to make a full thing. So somewhere I have this. So the synth is the thing that contains the full language definition for my thing, and so you can see it just sort of chains a bunch of these lower level parsers together. And the one we're looking for is this one, node definition, which is the thing that defines what these lines mean, where I actually define a new node in the graph. Well, there are other ways to define new nodes in the graph, but it's that particular one. And so here it is. And it itself is broken up into other things. So now when you think about what this is going to change. So I think really the only thing that changes here, and no, it's going to be several things, because so this guy call represents, go back to the original syntax, represents this. So this call to one of my predefined node constructors. And so what this is going to have to be is, instead of that, it's going to be an expression. No, I'm sorry. I'm confused. Call is a POM thing. What am I actually looking for? No, I'm in the wrong place. No, I don't know how my own code works. This is not the one. It's actually this here. So node definition is the syntax where I can dynamically define a new node constructor. So I'm not going to touch that. Sorry, that is not actually what I mean. Maybe I will edit that out to be less embarrassing, but probably not, because I kind of like things like this that have the mistakes in them, because humans make mistakes. And fumbling through that stuff is a big part of this process. Okay, so now I'm looking in the right place. Sorry. Okay, so this is actually my node definition, or my node declaration, I guess. And so I set up what a number is. Do I even use that? No, that's dead code, because I replaced all that with my expression parser earlier. Okay, so first I define what a parameter is. So parameter is basically everything here. So it's a comma-separated list of expressions surrounded by parentheses. And you can sort of see that here. They start with a parenthesis, an open paren. This says combine this with the following expression, but don't save this value. So you just throw that token out. And then the inner stuff is a list of expressions, and list is a POM thing. Expression is something I defined, separated by commas, and then followed by a parenthesis, which gets thrown out. And then I've marked that as optional because things like noise don't have parentheses parameters because they're just the node is parameterizable. Cool. Okay. And then the actual thing is this, where I say I want a bunch of characters, one or more characters. And this looks a lot like regular expressions if you're used to that. Just the syntax is different. So one or more characters which are not a new line in equals or parentheses. So this is, this stuff, stopping at the equal sign. And we just convert that into a string because that's the type we're going to want it to have. And then we jump over the equal sign, which has to be there, but we throw the token out because we don't actually care about it. And then it is... okay, so here's the part that's going to start to change. So here I'm saying, give me a bunch of one or more characters, without these sort of terminating things. And that is going to be used as the name of the constructor. So it would be this part. And that's what's going to change. And then that's followed by parameters, which again is optional. And then a new line. And then once we've got that, we have these things that I parsed out. I'm gesturing at the screen, which no one can see, which are going to be the key, the name of the node, in the name of the constructor, very good variable names, and p, the parameters, which is an option. It might be none. And then we do a bunch of stuff with that, which I'm going to think about in a second. So let's think about a version of this that would give us what we want for this new thing. And basically what that is, everything after the equals, so I don't care about parameters anymore. I'm still going to need the parameters because there's going to be places where I have to call a constructor. So what I probably want is I'm going to want a new parser. Okay, so this parser is going to represent a call to a constructor. So this is this or this, which could appear, I'm going to make it so it can appear in any expression in the system. Or also, more complexly, like this is also a call to a constructor, which contains a call to a constructor. And that's where this starts interesting. Okay, so the constructor call is where I care about parameters. I think I have to wrap this in a call because this is going to be recursive. And that is what POM needs you to do for recursion. So I'm a poor typist in general, but I recently moved to a new keyboard, and I'm more poor now than I used to be. Okay. So now let's see. Okay, so now I'm going to say parameters contains expressions. That's going to be recursive because in a second I'm going to say that expressions can contain constructor calls. And that's where we break that recursive loop. Okay, so here this stuff is the same. I still need the name of the node I'm creating, so that's fine. Maybe for clarity, let's just, while I'm explaining this to someone who's invisible, actually make it so it's readable. I think that's parentheses I don't actually need. Okay, so that's my node name. Node name. Okay, and okay, so this part is where I get the name of the constructor itself, plus the parameters. Okay, so this actually is gonna, oops. Okay, oh, there we go. I'm gonna need it up there eventually. Meanwhile, what I'm going to say is everything on the right-hand side of the equals is actually an expression. Which can be, any arbitrary thing. Still terminated by a new line. Cool. Okay. And let's give these guys better names. You're a node name now. You're there's no longer 3 of them. So the node name and then the expression that defines that node. Okay. And again, I'm going to think about the interior of this in a second because I'm not totally sure yet what it's going to need to do. Okay. And then this is constructor call plus parameter. I guess that's the whole call because it's the name of the constructor plus any parameters that it might have. Cool. Okay. So now I just need to now I just need to convert this into my intermediate representation. So I do that by calling map, and map takes takes the 2 things that I've got, which are the 2 things that I've got, the constructor name and the parameters. Yeah. Okay. So name and parameter. I should probably pluralize that elsewhere because there are potentially many parameters. Okay. So now I'm going to figure out how to do this. So the so here's where this gets tricky because I need to, even in places where I'm pipelining or composing, whatever, like here, in the live coding language, that's just part of this expression. It doesn't have a name, right? But in the underlying graph, it does actually need to have a name. So I have to make an anonymous node in the graph, and the see, so the structure of this may not work, because here's the place where I know the node that I need to create. but I don't know where it's going to live. Like, I don't know if it's inside an expression or what. Let's see. So how do I do this with the expressions? Because the expressions are the other place where I'm potentially creating. I'm already creating anonymous things. Okay, and there I've actually got my expression, grouped expression, where did I put that? I have a term, which is a number or a node name. Okay, so here's the place where I'm gonna have to stick this. So this is the part I'm confused about. So right now, I've got term, which is, in my expressions is either a number or a node name currently, and now I'm expanding that concept, so it needs to be a number, a node name, or a node constructor, which is going to need to get converted into an anonymous node, and then that the name, the identifier for that anonymous node becomes the node name effectively. So it's still really just a number or a node name, but in one place I'm going to have to create an anonymous node, and in the other place I have a user-defined name for the node. And elsewhere I'm creating the anonymous nodes with, I'm just giving them UUIDs, because they have to have some name for me to be able to look them up. And that happens elsewhere in the code, but so I need to think about this. Okay, well, first off, let's just go, how do I identify a constructor? So it's like this. Constructor equals, I decided it's going to start with a uppercase I should probably start factoring stuff out, because right now I've got this concept of node name, which previously was just any character, or any character that's not these guys, and now it's more complicated than that. So let's just go ahead and do that, because I'm going to need this concept, and that's not where I want it. And this is starting to get complicated enough that I should eventually have to do real refactoring, but for now we'll just do this. It's got this weird lifetime wiggle, and then this is going to return a parser of that lifetime that takes a byte string and returns a string. Okay, and it's going to look basically like this. Node name. And so a node name is all lowercase. I have to look up some POM stuff because I don't want to have to write out. Yeah, whatever. I'm just going to. There's absolutely a better way to do this in POM, but rather than look it up, I'm just going to do this. memorizing the alphabet song in my head. Okay, so that gives me any uppercase letter. And so what I want a node name to be is... Wait, this is more complicated because a node name it's not just a string, because it is potentially... No, I have to split this out. Okay, so this is just a string. So the complexity here is a node name can be, say if I were using, instead of the constructor, that thing called noise, it's a name plus a port. So there's a default port of 0, noise, but I might, on a more complex node, I might have, port 1, port 2, right? And so this bit isn't really part of the name, but it's part of the identifier in expressions. So here I'm just talking about the name. So let's say, okay, this is actually what I want. Instead of saying it's uppercase, I want it to be just the lowercase. Oh, and numbers. And underscore, whatever. That's fine. That's a reasonable set. And again, I know there must be character sets somewhere in POM. I just want to look them up. Okay, so now a node name is any lowercase letter or number or underscores. I might need to say like it starts with a lowercase. Yeah, whatever. We will come to that later. Okay. So there's the actual node name, and this stuff is for the port numbers, which those I think are actually going to go back in here somehow. Okay. So this is actually not that complicated, but I just made some decisions, so let's record those decisions. Don't need that. I'm going to need it later because I'm going to want another one of these that is a constructor name. And since I don't have a predefined list of node constructors, you say if they were like keywords, I could just list them out, but they're dynamically or semi-dynamically defined. And so I need a rule. Okay, so node constructor, similar to a node name, so it's actually going to have basically all this stuff in it, but it's going to have to start with an uppercase, and that's what's going to distinguish them. So it's going to be uppercase, and then plus, I think that's the one that combines them and collects both. And then my convert is going to happen on both of those together. I might have to do some sort of collection. See if it likes that. No, it doesn't. So it is collect, I think, to get like actually all the match characters. Treat bound set not. One of. Is this the treatment? No. One of. What am I doing wrong? B. got caught like that. What does this error mean? Type mismatch in function arguments. One of. Oh, it's because of that repeat, I think. So here I need to say, let's just step back here. There's exactly one of these. Is that how this goes? Function, back function. Type mismatch function signature. So it expects a slice of U8s, and I'm giving it a vec of U8s. And this one, cleaning up the U8 traits. 37. Is it just that these are too long? That would be irritating. Oh, really? So just like the type isn't defined for long strings. That's frustrating. Okay, so that's I just edited out some stupid fiddling to get around some combination of a type limitation and my understanding of how POM works. So the problem was that I had these really long strings, and the type that POM wanted is just not defined for strings that long. So I just need to break it down into shorter strings, and then I did. And after that, it worked. So, okay. So now I have a reusable definition for a node name, which is any combination of lowercase number and, actually, any combination of lowercase numbers and an underscore. Let's just, for the sake of sanity, let's say that these have to start with one lowercase. And then they're symmetric with the node constructors. And I think that might actually avoid some problems later. And then I have to do the same thing I did here. There's something about the type that POM is producing that is just, I have to do this fiddle. There may be a more elegant way of doing that, but I don't really care. Okay, so now my node names consist of one lowercase letter followed by some combination of lowercase letters, numbers, and underscores. And then actually, let's say that can be 0 or more. Because who doesn't like one letter variable names? I clearly do. Okay, and the node constructors are the same, with the exception they must start with one uppercase. Okay, so now I can tell them apart. And I have reusable definitions. Okay, so now let's actually use some of those definitions. Okay. So now I'm back inside my expressions, looking at the terms in the expressions and figuring out how to add node constructors into those terms. And that is going to work with, whatever. I'm going to take a break for a second and then come back to this. Okay. So now I am figuring out how to put these node constructors into the expressions. So let's see. So I have my node constructor name. So I need to differentiate the term type. So what I need actually is not just the node constructor name, but a full node constructor. So this is actually sort of what I started to build down here. What did I call it? Constructor call. So let's actually grab this and move it up to where I'm going to use it. Which is here. Okay. So constructor call consists of a constructor name, which I've got a definition for. Nope, that's not what I called it. A node constructor name. Cool. Plus some parameters. And I'll figure out exactly how to do that in a second. But now I can say a term consists, a constructor is, I guess I really need to bind this to a variable, but that's fine. And then a term consists of a number or a node name or a constructor. And a node name is okay, that. I guess actually. Right, because I need the port number. So I need actually, it's not just a node name, it's a node, I don't know what the term for this is. A node reference. So, and a node reference consists of a node name plus a pipe. Don't really care about the pipe. Star says to discard that symbol. A star says to discard the previous symbol. A minus says to discard the next symbol. And then a number. Right? Port number is one of those. Any number of those. And the optionality of it is actually not on that, it's on the whole thing. So a node reference consists of a node name, plus a port, a pipe followed by a port number, and then that whole batch is optional. Okay. And then I need to convert that node reference into an expression term. Do that by mapping should just be this. This is redundant, and this is now called node. And why are you sad? Because the constructor is returning the wrong thing. So what do I want this to be? I'm only ever going to use constructor calls in expressions, so they can actually just return an expression, I think. Don't have to do this other thing, in which case I think this works now. No? These still don't work. Why is that? USize call. I am missing a grouping. Okay, still don't like it, and the reason is found expected function found parser requires expected view size found U8. So that is wrong. Oh my. Cool. Okay. So now my term consists of a number or a node reference, which is a node name plus a port, an optional port, or a constructor, which is this guy. And a constructor is a name and parameters. Cool. Okay. So now I need to figure out how to make this work. So I still have this question about how do I deal with the anonymousness under some circumstances and not under others. One way to do it would be to always build them as anonymous nodes and then bind them to names, leader. The only convenient way to do that in my current code would be to basically duplicate the node and have an anonymous version and a named version and then patch them together, that would totally work, but it would be slow. And I know that I'm already pushing up against performance bottlenecks with complex patches. So I'd rather not do that if I don't have to. And the issue here is that don't know whether or not I want an anonymous node inside this section of the parser. Maybe it doesn't matter, because my expression definition for node takes a name and a port. So I can just do this. I think this will work. So where my expression is, here it is. Okay. So an expression consists of a term or an operation. So what I actually want is term. A term consists of a node or a number, but now it also consists of a node constructor. Okay. And a node constructor consists of a string, which represents the name of the constructor, and a vec of expressions. This is... No, that's fine, because it's inside a vec. I was worried this is going to go... It's going to become recursive, but since I've already got it on a heap-based structure at the back. That doesn't matter. Okay. So now I have terms that are node constructors, and then when I actually build these things, I think at the point where I actually evaluate or interpret this expression while building the graph, I can know whether or not I need to make an anonymous node or just assign a name to this node. I think. Okay, cool. I'm going to believe that that's true. So that means this is structure, and it's just the terms. Structure name. No, should I call it something else? Did I spell it wrong? Constructor. Oh, sorry. Because it is this. Okay. You don't like that because, right, parameters is potentially optional. How do I represent that? Let's just make it real explicit. And the other option would be to have an empty bank of expressions. But I think this is probably clearer. Let's do that. Okay, so now I can build my terms. So now everything should parse the way I want it to, I think. Well, we'll see if it actually runs, but it's not going to build the graph well, because I've got this other thing, and in fact, it's probably won't even compile, because there's going to be places where I'm using term. And I have to find that code. Find that code in this stuff. Okay, so here's the place where it blows up, and what it's going to be complaining about is I'm missing a branch from my new constructor thingy. And so here's where so what's going on here is this is inside my definition of expression. I am converting this into explicit representation, which I'm calling line of the thing. So I'm basically unpacking the expression into the things I need to build into the graph. Line is not a good name for this, but what it is. And so here you can see in places where I have a number, I am actually building a node with a name that's a UUID and a type that's just a constant. And then I'm passing that into the receiver for that number, which is the outer node that's being defined, target node and target port. So this is going to be pretty similar to what I do for my node constructors, except instead of this constant, I'm going to be building something else defined by the node's constructor name. So I'm still missing what happens when I have the outer name. What do I do? That's because this is explicitly not represented here, because it is a case that I didn't previously have. This is so like when I was building these nodes, I would parse a node name equals node constructor parameters directly into one of these line node variants, like this, where this is the name that the user supplied in the code, and then this is the type, and so now I need to handle that case where I have an expression that consists of just a single node constructor. And that is the only place where this is complicated, I think. Which means I may not really have to do anything here. No, I do. Oh man, why am I having trouble thinking about this? Okay, let's just start typing. This is my constructor, and this is my fingers. Okay. Constructor name. Okay. So the parameters are themselves just a list of expressions. So I can. No, how do I do that? How did I do that before? This. Okay. I've forgotten how this code works. It's fine. So before, when I was doing this, I was doing it with a node here. This is code that's actually going to go away because I think I've now completely replaced it. I think. No, I still need the naming part. Right. Okay. Cool. And so here's where I do it. So now I have node name plus an expression. Right. Okay. And this is complaint. Okay. Now this makes sense. So this is complaining because this expression is returning an expression rather than a line, which is what we're expecting, rather than a string. No, what is complaining about? Okay, whatever. This is my list of expressions. So if, now what I'm calling it, so if this is a sum, then but no, it's no longer optional, right? So this is, let's start over. So now I have, in this case, I know I'm going to need to build a node. So this is my basic thing, and that node is going to have a name. And here, okay. And so now I'm back to my fundamental problem is what is that in? I know the name. I no longer necessarily know the constructor because there may not be a constructor here. So what I can do is I can go, I can match. So match expression. It's going to be either a single term. It's going to be single term where the term is a node constructor. Like that. So that's one case. So this represents the previous case where I just had a name and I'm assigning it to a constructor to it. Or it's going to be something else, which is any other case. And in all other cases, like that, what I need to do is make an anonymous node that is sort of the receiver of that expression. Otherwise, I can just do the thing I normally do. So, and in that case, yeah, here's where I actually needed that code that I just deleted. Let us, there we go. Okay, and so here I am in this case. I'm gonna make. Okay, so now I know I have a, and this was, go back to what I was calling it before. And then like this. Okay, so this is literally my initial case, except that my node name has changed. Okay, so now in my case where there's a single constructor and I'm just assigning a name to it, then I just do exactly what I did before, everything's fine. And then this is the more complicated case. And it is really not that much more complicated, I think. So I just need to make a node, and it's going to be called whatever node. It has a name. I know what the name should be because it's supplied by the user. Its type is going to be C, which is my identity. What do I actually call that? I guess it's C, which means that there's somewhere else I was using C incorrectly. That's going to cause a bug later, but whatever. And that's fine. You just build a constant with that name. Where a constant is an identity that takes an expression and just returns whatever the value of that expression is. Is it just a holder or a named handle? Okay, and then I have the actual expression, which I need to do all of this stuff to. I'm calling this edges, but it's really not really what it is. And the edges are, in this case, it is the whole expression. They really are. They're super symmetric. Okay. Except not that. This. Right, because this is not actually optional in this case, so not that symmetric. In fact, really not at all, because it is, since there's just the one expression. It's like this. Port 0. Okay. So it's actually simpler. Not E, but does that do what I need? I think it might. Let's just see. So now I handle my two cases where I have a named constructor, exactly like it was before, a named node that corresponds not to a single constructor but to an expression, in which case I just make a placeholder node and pipe or patch the result of an expression into it. And I think that will just work. Oh wow! See if it compiles. No. Some sort of typo. And it's just me pounding on keys. Right. Right, okay, so I still need to handle this case. And what do I need to do here? Okay. So let's see, what do I do here? What lines do I omit? So this is always going to be the case where I am internal to an expression, because I've already handled the case where the outer thing is a node constructor. And that means that in this case, I will always need an anonymous node. That's true. Okay. So that means it is very similar to this. I get a node name. We make a node, but instead of making it as some random type, we actually know what we need. We need constructor. That looks super wrong to me. Constructor name. And don't actually need to build anything here. So this is one. That would just contain like a pre-built node if I need to. No, complaining about. Oh, show me the error. Construct. That looks wrong. It is wrong. Now this. Okay, cool. So I have a node of that type, but I know I've got these internal parameters that I need to deal with, I can do those by just calling this recursively on each parameter, which might be optional. Okay. Some parameters equals parameters. Then I need to go through each one because there's each parameter in this list corresponds to an input port on the node. So I know the input port, call that I, and then the expression, call that E, for enumerate, because that enumerate gives me the port numbers. And then for each of these, I'm going to extend my list of lines with whatever this expression turns into when I go e.as lines. The target node is in, that probably shouldn't be a string, should be a reference, but whatever. And the target port is I. Cool. I don't like that. Why? For okay. I think that probably does it. See if we compile. It does not. But now we're at least in a lower level of the compiler. A later pass, I guess. Lowercase moved. Okay. One of lowercase. And it is indeed moved. Okay. So that should be fine. I can't clone it. Really? There is probably a more elegant way to do this. That gets the job done. Okay. Cool. All right. Thing. And is that push? Did not make this mute. Okay. And that. No definition of sign. Oh, right. That is the other thing I need to do because I have changed these. This may not be the best abbreviation to use for this. I did not notice that. These all need to start with an uppercase. Can I don't know that I've ever actually tried to do this with Kakon. I bet it works. Hey. Okay. So, let's see. No definition for sign. No definition for sign. Oh, didn't get them all. No definition for mole. Okay, so this is coming out of my expression builder somewhere, which is doing this. Okay. No definition for C. I think I've used that a couple of places. You know, I just wrote that in the code I was looking at. Do I do it elsewhere? right? This is the place where I was. Here, this name doesn't actually really matter because I'm not using it to find a predefined constructor. Instead, it's just it's used to identify the type of node when the graph reloads to see if that type has changed. So it just needs to be unique. It doesn't actually matter what the value is. Cool. Okay, so that thinks it's running. That's a step in the right direction. Okay, let us start over because it made that into gibberish. So now we have an oscillator. It's going to be a sine at 220. Okay, that is real quiet. Cool. So that means that my base case, what I was doing before, that works. But now can I do something like, let's say, have an LFO directly in here, an anonymous LFO, because that would be super awesome. That's a P sine at 1 hertz. No, didn't like that. So what is going on? So there's one of the problems with my parser that I need to figure out at some point. Maybe this is the point. Is that if it fails to parse in certain ways, it just stops with no error. And I think that's probably what happened here. Yeah. So if I make my LFO like this, that's fine, and then go. All right, so that's what I was expecting here the first time. Okay, so that means that for some reason, this just isn't parsing, I think. Okay, so let's figure out why. So it is probably somewhere in this. I probably have this wrong. So, well, I mean, I know this is working for the case where there's only one constructor because I saw that case work. So, and it's working where there's node references and numbers, because I saw that case work. So, okay, so let's just do some print line debugging. So this should show me something. If we hit the case where there's to show me which constructors we try and build. So I should see P sine sine and P sine again. P sine. I get parsed twice. That's not sure why. P sine sine, P sine sine. Okay, so that implies that it is actually parsing. So my first theory was wrong. Okay, let's take a look at what the values of this actually are. I'm going to expect zeros. Okay. So now I'm back to thinking I was right the first time, because like the fact that this isn't printing anything implies that it stopped parsing at this line. But we know it got as far as running this constructor call with the right value, which means something is going on here. Term, grouped expression. Or remember if I'm allowed to debug print these or not. Be real convenient. No. Not improving. Okay, so this is the place where it actually matters. So here I have an expression. This I should be able to print, I think. So my expression is the term sign, which is correct, and is the node constructor, right? And node constructor has parameters. The parameters are an operation which consists of two terms, a multiplication of a number by another node constructor, which itself contains the parameters. So that's the correct parsing. So that part's working. And okay, so let's try this. Let us try this other case just to see if this is working. So this should be a constant value of 1. Let's see. Okay, so that's also not printing anything. That's also not printing anything. Oh! Because this has changed names. So none of that meant anything. I'm just dumb. Now contains value of 1. Great. Okay. So now having remembered that I just made that change minutes ago, see what this looks like. Okay. So that's doing something. It's just not what I expect. And that's, sorry, I was hearing the humming for a second. I wonder if that was coming out of the computer, but it is an airplane passing overhead. Okay. So I think that sort of implies that this p sign is not getting routed correctly, because I think if we go that times 0, we're going to see the same. Right. Yeah. So this is somehow not getting routed correctly. So that implies that the problem is not here, but not here. Node name. Yeah. It's not here, but up here where we do the as lines. And where I have a node constructor. And so this is going to be this case here. And I give it a name. And I don't connect it back to the target. Okay, so I just left a dangling connection here. Yep. Okay, cool. That's an easy fix then, assuming that's the only problem. This is a little bit concerning because now that I'm building these guys here, when I'm making these constants, like I know there's only one output port. In this case, I'm building these more complex nodes, which may have arbitrary output ports. But I'm not actually able to parameterize that. And I think I'm just going to fix that when it becomes a problem, because in most cases it will be fine. Okay, it's still not working. No? Okay, that's what I expect, which is super awesome. But the question is, why did it not start doing that on load? Now it is. Oh, because I probably hadn't written the file and I just had the 0 in there. Okay, I think that's fine. Okay, cool. So now I have pipelining, or composing. Okay, so let's do the thing that actually triggered me to build this. I was doing a lot of complex filtering on noise, stack filters and stuff. So let's just make sure I can do that. Just click off this because that's annoying to look at. Okay, so I'm going to do a low pass filter of whatever. And the input is going to be noise. So, hey, that's pretty awesome. And now I should be able to stack this arbitrarily deep. Hey, and that does what I'm expecting. Okay, cool. Now I don't have to write node raw 2 anymore to explicitly create all those anonymous nodes that never needed to exist. Okay, cool. That is that change, and I am happy that works. And I will commit that and then maybe make some sound with it. Cool.